Welcome all. In this video we are going to talk about the properties of glucose. Okay, some of the properties like a reaction with HI gives NHCN and the reaction with bromine water gives gluconic acid, reaction with tolerance reagent gives silver, reaction with filling solution. These properties we have already seen in the structural elucidation of glucose. So you have to refer those notes. Some of those properties is discussed in that video. So we are going to discuss the remaining properties of the glucose. So glucose is highly soluble in water, okay, but a little bit sparingly soluble in alcohol. That we have already discussed in the last video, which gives the chance to separate the glucose from the fructose. Okay, insoluble is ether also. So glucose shows mutarotation. Mutarotation is a process in which one of the alpha form, okay, one of the alpha form or beta form, mutarotates. That is, they change into an equal amount of alpha and beta form. For example, an alpha form of a glucose has a specific rotation of 112 degrees. Okay, that is dextrotation, and beta form has plus 19. But if you leave those glucose in water, either alpha form or beta form, okay, so they will change into itself. Like alpha form will get converted into beta form. If the beta form is dissolved and kept, it will convert into an alpha form. Okay, beta form converts into an alpha form. 50% of beta form should be there, 50% of alpha form would be there in a solution. That is, if there is an 100% of alpha form, from the 100% of alpha form, like let's take 100 molecules of alpha glucose is there. So from the 100 molecules of alpha, 50 molecules of alpha will convert into an beta form, and there will be a dynamic equilibrium that we won't go into it much. So 50 molecules will convert into beta form, and the optical rotation, alpha form has plus 112, whereas beta form has plus 19. Okay, so if it converts from alpha form to beta form, the rotation reduces to plus 53. If the beta form converts into an alpha form, the rotation increases from plus 19 to plus 53. So this is the property of mutarotation. That is, mutarotation is interconversion of an alpha form into a beta form. Okay, so the change in the optical rotation until a constant value is obtained is called as an mutarotation. It is characterized by acid or base. So basically, it is attained partial in presence of acid or base. Okay, so glucose does not react with ammonia, sodium bicarbonate, and Grignard reagent, unlike the aldehydes and ketones, because of that cyclic structure. Because cyclic structure prevents the aldehyde from reacting with ammonia, sodium bicarbonates, and Grignard reagent, whereas normal aldehyde will react with normal aldehydes will react with ammonia, sodium bicarbonate, and Grignard reagent. There is a difference in the aldehyde group present in the glucose. Okay, glucose does not also give shift test. Basically, it does not react with an amine, and aldehyde reacts with an amine to form a Skiff's base, Skiff test. This is not given by the glucose. So when bound with a concentrated NaOH, glucose first turns into an yellow, then brown, and finally gives a resinous mass. Okay, with the concentrated sulfuric acid, glucose undergoes dehydration. Concentrated sulfuric acid is a good dehydrating agent. Okay, it removes the water from many molecules. So it removes the water from the glucose also, and forms methyl furfural. So how many molecules of water is lost? One molecule. Here OH, 1, 2, 3 is basically 3 molecules of water is removed. Okay, which gives hydroxymethyl furfural. So this is the product formed with sulfuric acid, constant sulfuric acid. Okay. So when warmed with dilute NaOH, glucose is first converted to fructose. That's an interesting thing, because glucose and fructose are interconvertible in presence of a base. and also it will convert it into an mannose. Okay, so D-glucose and D-mannose are epimers, which are a pair of diastereomers. Epimers are diastereomers, which differs in only a single carbon atom. Single carbon atom, that is OH, may be present on the different side. For example, in the mannose, see the this is the glucose. See the second carbon. Second carbon, the H is in the left hand side and OH in the right hand side. Whereas in the mannose, the OH in the left hand side and H in the right hand side. So all others are same. Okay, all others are. So this is what is called as an epimers. Okay, which differs only in the configuration of the single carbon. Configuration of the single carbons. The groups attached in these two carbons are same, but the way in which they are attached is different. That is called as a configuration. So here fructose is a, you know that it is an keto. It consists of keto group, so it is an keto exose. So here keto group is there. Okay, with concentrated HCl, glucose gives levulinic acid and formic acid. Okay, levulinic acid is CH3, CO, CH2, CH2, COH with concentrated HCl. The glucose gives levulinic acid and formic acid COH with a water molecule. Okay, so glucose reacts with the phenylhydrazine to give phenylhydrazine zone. Actually, it should be a zone. It's wrongly given as zine, so it should be hydrazone. If excess of phenylhydrazine is used, dry hydrazone is called, which is called as an glucose zone, which we have discussed in the first video, I think. So it forms a glucosazone. Okay, by which is formed by the elimination of aniline and ammonia. So this is the reaction. This is the first hydrazine formed. Okay, so this is the next one with the second two molecules of phenylhydrazine. Okay, so one molecule of aniline is removed and then one molecule of ammonia is removed as shown in the reaction. So this is glucosazone. Okay, glucosazone. Okay, so next one is glucose on reduction with sodium borohydride. Sodium borohydride is a reagent which reduces CHO to CH2OH. Okay, so the aldehyde group present in the glucose is reduced to CH2OH, which produces sorbitol. Basically, the topmost carbon CHO would have reduced to CH2OH. Okay, the CHO is reduced to CHOOH. Sodium borohydride is a specific reagent which reduces an aldehyde to an alcohol. Okay, so that is the end of this video. For the properties, I think if the question is asked about the properties of an glucose, you have to write the properties. In the structural elucidation, I think to recap, it reacts with an HA to form an N-hexane. It reacts with acetic anhydride to form a pentacetate. Glucose reacts with tolerance reagent, ammonical silver nitrate to form a silver, and Felling's test, it gives red precipitate of Cu2O. Okay, with HNO3 it gives saccharic acid. With bromine it gives gluconic acid. So these are the other reaction you have to study of the glucose. Okay, with this we will end this video, and we will meet with the other types of carbohydrates in the next video. See you, bye.